All right, we are back for the second part here. Okay, so we are on page 20 now. We're at the bottom here. So we have this quadratic equation, which has been factored. And then now we're going to do the new part, which is the solving part. So using the fact that we have to have one of these numbers be equal to 0 in order for their product, when I multiply them, to be 0, we can separate into two equations. So either x minus 2 equals 0 or 5x plus 6 equals 0. There's also the possibility that both of them are true, and that's something that we'll get into more again in Math 100. So for right now, we would just finish these two, and these are back to equations that you learned how to do in Math 38. So x minus 12 equals 0. You're going to add 12 to both sides. Oops, 12. And then x would be 12, or, and it's always a good idea to keep putting that or in there to remind yourself. You got to have both of these as possibilities. And then we'll subtract 6 from both sides. 5x equals 6. Divide both sides by 5, so 6/5. So for this one, x equals 12 or 6/5. And those would be the answers to that quadratic equation. So we're not just, it's not just a trinomial that we're factoring anymore. We have this added part of it being equal to 0. If it wasn't equal to 0, we can't do this. And this becomes very, very important later on when we have to do some manipulation with our algebra to get it so that it does equal 0. We may have, like 5 over here, and then we've got to first get everything over on one side of the equation so that we have 0 on the other before we can continue to use this process. So you got to make sure that it is set up properly, and then you can use this. So that is the extent of the new part, is taking each piece that's multiplied here, setting it equal to 0, solving those. We should check those answers again. So check your answers to verify that you're getting a true statement. So we should go back to our 5x squared minus 54x minus 72 equals 0 and put in each of these. So 5 times 12 squared minus 54 times 12 minus 72. Does that equal 0? And definitely a point at which you can pull out your calculator. Let's see here. Okay, yep. And I am getting 0 equals 0 for x being 12. And then trying the 6/5 in there. And if you're getting any weird answers here, you might want to look at 6/5 as a decimal. 6/5 is something that will have a terminating decimal. It's going to be 1.2, so it's a little bit easier to deal with here. All right, let's see here. Okay, so I am actually getting minus 57.6, then minus 72. Okay, so obviously that is not going to be equal to 0. So we are going to have to throw that one out. It's called an extraneous solution. So an extra solution that doesn't work. So we are only going to want to include 12 as our solution. So here, right here, is why it is so important at this point that you make it a habit of checking all of your answers. It doesn't have to take a long time. You can just quickly check these in your calculator to make sure that they do work, but it is going to save your rear end because otherwise you would have put both of those in and Alex would have said that's wrong. So, make sure that you are, and of course I can give you partial credit in certain situations, but that could make Alex very frustrating if every time you're like, I have 2 answers, why won't it take them? I know I did all my work right. Well, you got to check them. You have to check them back into the original equation. And always go back to the original equation. that helps make sure that you didn't make any silly errors as far as reading the equation improperly and writing it down wrong on your paper to begin with. Okay, so enough for my strategies on that. So moving over then to page 21. So a little checklist for this using this solving method for quadratic equation. So write your equation in standard form, and that means it is solved for 0. Okay, must be solved for 0. Factor completely. Use the zero product rule to set each factor equal to 0. Solve each resulting equation, and then check your answers in the original equation. Yeah. Okay. The next one here, and right away I'm seeing that it's not in standard form because it's not solved for 0, meaning we don't have 0 on one side of the equation. So we do need to do some manipulation here with our terms. First, multiply. We're going to do the distributing. Multiply that x throughout the set of parentheses to clear those. So 9x squared minus 12x equals -4. And then we want to get 0 over here. It's easiest to move everything to the left-hand side because I only have one term I have to move. And then this will be 0 over here. So 0, and then we have 9x squared minus 12x plus 4. Okay, then we are looking at factoring this. So think about your factoring completely checklist. The first thing we're going to do, it's in descending order, so that's good. But then we look for a GCF that will work for every single term. And there is not one. So 9, 12, and 4, there is no common factor for all of those. And, you can go off to the side and make little factor tables for these guys if you're not sure and see, all right, is there anything that's on all 4 lists? And, there is not. We could get 2 of them. So if I only had, to deal with 9 and 12, or I only had to deal with 12 and 4, then I could have a common factor. But for all 3 of them, there is not one. So I have to deal with this trinomial as it is. And I'm kind of hoping that it's going to be a perfect square trinomial because that makes my life a little bit easier because I can use the shortcut instead of having to use the AC method. And we've got 9x squared and 4, both of which are going to lead me to think, those are perfect squares. So think about what those square roots are. So we'd get 3x and we would get 2. All right, so we would say 3x times 2, but then we're going to double it. And that is going to give us 12x. And hey, that's the middle term that I have up there. So that is verifying for me that this is going to be a perfect square trinomial. So that means we'd have 3x and 2 quantity squared equals 0. And then remember to grab the operation symbol that is here on your middle term. So it'll be subtraction there. And, go over here and, or, on your scrap paper someplace and FOIL that out if you're not sure. Make sure that your factoring is correct. Because if your factoring's not correct, nothing from here on out is going to be correct either. So this would be 9x squared minus 6x plus 4. And yeah, once I add those 2 middle terms together, we would get 9x squared minus 12x plus 4. So I do have it factored properly. Now you can write it squared, which I'm sure Alex would prefer, but you can also think about it like this, which may be a little easier in this context because we want to make sure that we're setting each factor equal to 0. So then we say, all right, 3x minus 2 equals 0, or 3x minus 2 equals 0. Okay, so it's a repeated factor, right? It's the same factor multiplied by itself. That's what squaring means. So we're going to get the same thing on both of these. So we'll get x equals 2/3 here, or x equals 2/3. double check. I'm going to put that up above because I'm running out of space here. So go back to our original equation, and I really mean the original equation here that we've got. So we're going to say 2/3 times 9, the quantity 9 times 2/3 minus 12. Putting this in brackets just to, differentiate them from the parentheses I'm using for substitution. You could just use another set of parentheses here, but for my eye, it's a little easier to do this. And then I'm going to, go to my calculator, or, make sure you leave this until we get all the stuff cleaned up inside the parentheses. If I think about this one here, 3, so I'm going to get 6 minus 12 in here. And it's sometimes easier to work a little bit with this instead of trying to just plug this all in your calculator and see if it equals -4. That way you don't have to write, don't have to put quite so much effort into trying to plug it into your calculator correctly. And then this would give us -6/1. And I forgot my question mark there. Are we checking that? And is that going to be -4? And hey, we have a 3 that will divide out, leaving us with 2 times -2. So we do get -4 equals -4. So x equals 2/3 is the correct answer. So I did put a little box around it down below there. So x equals 2/3. Now you can put it in twice because it is a repeated answer. It's the same one twice. I'm not sure how if Alex is going to want you to put both of them in, or if it's going to be satisfied with just one. So let me know if you run into that, and tell me what Alex thinks about that. I will try to do a review problem and see what I get for that. And then that is it for that new idea as far as getting it set equal to 0, getting it factored, which is not a new idea. That one we've been working on for a while. We get it factored, and then setting each of those factors equal to 0. And then when I get those answers from those linear or first degree equations, plugging those back into my original equation here to see if I get a true statement. Now, mostly we are going to be focused on quadratics, so things of degree 2. But we can use this for a degree 3, and they might throw this one at you at some point in one of your problems. So I'm going to make sure you're prepared for that. So the idea is just if we can completely factor it and get it set equal to 0, then we can still use the 0 product rule. We're just going to have more factors. Instead of just having 2 factors, we will have 3 or 4 or however many. So solving this one first, because as far as getting everything on the left side, that way I have 0 on the right, and then the left is going to be 10x cubed plus x squared minus 2x. And here I notice that I do have a variable on every single term, so an x is a greatest common factor here. There is no other numerical portion to that greatest common factor other than 1, because there aren't any other common factors with those coefficients as they're written. So pulling that x out front then, we'll get 10x squared plus x minus 2 equals 0. And then I'm going to want to look at continuing to factor this, and I'm going to use the AC method over here. So AC would be 20, so 1 and 20, 2 and 10, 4 and 5. So I figure out which pair is going to add or subtract to 1x. So I am going to have to use the 4 and the 5. And don't forget that that x is still hanging out front. It's important. Then we will have these two terms set up with 4 and 5. Oops. I'm a step ahead of myself. Sorry. We are going to use that substitution of I'm going to do -4x and +5x. I'm going to stick that in instead of +1x. Is everyone seeing how that's going to be a +1x? Which is why I'm using positive 5 and negative 4. So plus 5x